Okay, so let's do in class number 11. So it's here. So we have a population of 250 million people. Suppose 50% are in support and 50% are against some issue. We'll take 1 to mean support, 0 to mean against. And suppose there's 250 people from our population were surveyed and asked whether they supported the issue. Suppose further that 30 different surveys of 250 people were conducted. So the step below shows results of each survey, where each number in the set represents number of people in survey who support the issue. So this would be the first survey done here, and that survey, out of the 250 people, 135 supported the issue, and so forth. We have 30 different surveys. Okay, so then we have to write the R code that does the following: computes the sample means, computes the z-scores, creates frequency histogram of the sample means with breaks at these guys here, and then the last part creates density histogram of z-scores with breaks here and overlays the standard normal. Okay, so let's do the R code. So R code here. Okay, so first thing is our p-value is 0.5. That's the given at the beginning up here. It says 50% are in support, so that'd be 0.5 would be our p. And then our q would equal 1 minus p. Okay, our n, that's our survey size, which is 250. Okay, then we need the standard deviation. So it's going to be defined to be the square root, so SQRT of P times 1 minus P. Okay, we're going to need the standard error, so SE, and that's defined to be the standard deviation divided by the square root of n, and our n is 250 in this case. Okay, actually, if we go like this, I don't know if this is necessary, but I'm going to add it here anyway. Oops. All right, so now let's start doing the sample means. So let's call the first one x1. It's going to be then, so actually let's take our data up here and paste it down in the R code. So down here, let's put it right here, I guess. Okay, so our x1n would be defined to be, the first guy is to be 135, and it'd be divided by 250. You can just call it n since we defined n to be 250 up here. Then semicolon, then the next one. So next one, I'm just going to actually do this. I'll explain why in a second. Actually, I'm actually going to do this to speed things up. Let's just get rid of this actually for now. So let's just take this guy, paste it below here, and then I go x like that. And we're going to have to replace these with a 35 semicolon. So it'll be x1. The next one will be x. Actually, I'm just going to actually copy that. So next one will be x2. We want the next one. We'll paste it here, this guy here, so I can just speed things up. 3 semicolon. Oh, sorry, you need to divide these by divided by or n divided by n divided by n. Next one, x4 divided by n, and semicolon. Then, oops, get rid of the comma there. Then x5 divided by n here, semicolon. So x5 would be 126 divided by n, and semicolon. Get rid of the comma. And we're going to keep going like this all the way until we get to the end. I'm just going to do it. So pause the video and do it, and then come back. Okay, so here's I've done all the sample means. So let's get going then. So then we're going to say sample means, define a vector, sample means, and it's going to be then vector. So start putting x1, x1, x2, all the way until I get to x30. So I'm going to pause the video again and do it. Okay, so here's the finished product. Okay, so let's keep going then. So we're now all the way to x30 here. So define my sample means. So then I'm going to write print. I'm going to put this down here. Look at it here. So I'm going to say print then quotation mark sample means. So when I look at the R output, I'll be able to identify the sample means. Then right below here, I'm going to write sample means. Okay, so I'll do the sample means. And now let's move on to the z-scores. So I'm going to write, so the z-scores are defined, let's do z1, say it'll be z1 will be defined then to be our x1 guy minus our p divided by our standard error and semicolon. I'm going to keep doing that for all 30 of the z's. So I'm going to pause the video again and do it. So after I finish, this is what I get, all the way to 30. Okay, and now let's keep going here. Let's define our sample z-scores. And z-scores, that'll be the vector c. So it's basically going to be z1, z2, comma, all the way to z30. So let me pause the video and do it here. Okay, so I'm going to go all the way up to 30. I get this. So that's my sample z-scores. I'm going to write below this print sample z-scores. So print quotation marks sample z-scores. Okay, then right below here, sample z-scores. Sample z-scores. Okay, so now let's do our histograms. So the first histogram is of the sample means. So I'll write my sample means. And we had breaks. Let's go for the breaks for the sample means. Looks like here's the breaks for the sample means. Put that down here. Okay, so that takes care of that one. Then we have to do a histogram for the sample z-scores. So histogram, that'll be sample z-scores. Okay, and the break for this one. Oh, actually, we want to do a density histogram. So you're going to say frequency false. Oops. False. Then we put breaks for our z-score guy, which is given up here, right here. Breaks here. Breaks. Okay, take that. here, and another quotation, parenthesis at the end. And that would be it for that one. Then we have to overlay our standard normal. So you're going to write curve, then write d normal, or norm, x mean. So it's a standard normal, so the mean is 0. The standard deviation is 1. And let's say the color of this guy, let's choose it to be, doesn't matter, say red. And then we're going to add it to our histogram. So you write add true. Okay, so that's our R code. So let's copy this now into run our script and run it. It starts here. So we're going to run our script, our command, there it is. Okay. All right, so let's get rid of this. Run it here. Okay, let's scroll down. So there's our output there. So let's copy this into our Google Doc. Down here. So it gives us the sample z-scores, gives us the sample means. Okay, and let's do our histograms at the bottom here. Look here. There's our histogram, frequency histogram. Copy that one. Paste it here. And let's do our z-scores. Paste it here. So you can see the z-scores. Actually, let me look at this one here. The red guy is the standard normal, so you can see the z-scores, a histogram, are close to the standard normal, which we expect from the central limit theorem. So that's good. Okay, so that completes in class 11 then. So we have our histogram here, and then we have our sample z-scores, sample means, and then our R code. Okay, so let's leave it there.